Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 39 to 44 of the CBEST Mathematics Practice Test. All right, let's take a look at question 39. The question is, which of the following numbers is between 2,329,500 and 2,598,100? So the best way to do this is to take a look at these digits and basically see where these two numbers fall in, okay? If you can put one of these numbers either above or below any of this number, then you can have an idea as to where the other number is, okay? So let's look at the bigger one. The bigger is 2,598,100. So if I can find the number that this is greater than, then this other number is automatically going to be smaller than that number, okay? All right, so we have 2 million. Forget about the twos, okay, because they all have twos in common. Then in the 100,000 place, you have 5. So we have 5 here. So these two are neck and neck right now. And you have a 9, and then you have an 8 here. So what does that tell you? It tells you that the bigger of the two numbers, 2,598,100 is greater than 2,589,200. Okay, so what can we conclude? We can automatically conclude that this number is going to be right here. Okay, but let's assume that we don't know. Let's just verify. Okay, so we have ignore the 2 because they'll have twos, and then 3s. So this has a 2, so this is way below this. We're looking for the number that the biggest number that's smaller than this, okay? I meant to say the biggest number that's greater than this and smaller than that, okay? So we have 2. All of these are smaller, that's good. And then you have 2. And then we can eliminate this. 3, 0. This is smaller than that, you can eliminate it. And then you have 2 here, which is 2, and these two have 2's next to them. Okay, and if you move to the thousands place, 9, you have 9, eliminate that. So these two are neck and neck. We want the number that's we're looking for a number that's bigger than this one right here. And then we have 3, and that's a 5. So that automatically tells us that this is smaller than that. Okay, the only number that's bigger than this number here is 2,589,200, and it also happens to be smaller than the upper bound. So we can see that the only digit between these two numbers is basically option letter E. Okay, so what this is saying in essence, let me write it in inequality notation. Just imagine that you have a number line like this, and this is the direction of increment. Okay, so you're increasing as you go in that direction. So you have this one right here, 2,329,500 comes first, and then you have 2,589,200. This is less than this, and this is less than the biggest number, which is the upper bound, 2,598,100. Okay, so this is the number that's in between this number and the other number. Okay. All right, let's take a look at number 48. Very similar to number 39. It says if the value of x is between 0.051 and 0.038, which of the following could be x? So let's take a look at the bigger one again. We want to find the number, the biggest number out of here that's less than this. Then automatically that will be greater than this one, all right? Because that's how the problem is set up. So 0.0, all of them have zeros. They have zeros in the 10th place. And then 3, we're looking for the one that's smaller than this right here. So we have 0.038. Let me put it in to the right. So we have 0.038. So what's the biggest number here that's less than this? Okay, 3.0 0.06 is too big, you take that out. 0.05, that's too big. We're looking for 3 or less. Okay, you take that out. 0.04, 4 is greater than 3, that's too big, you take that out. 0.02 and 0.00, these two are less than this. Okay, but which is the bigger of the two? 0.0261. So we can put that right here. So we know for a certainty that 0.038 is right here. Then I can automatically assume that this number, the smaller of the two, is going to be less than this number right here because there has to be exactly one answer. Okay, so you have 0.0051. So the question is that the case? Is 0.0051 less than the next number in this alternative that's bigger than this? Well, compare it to option A. Is 0.051 greater than option A? Absolutely. So we see why this is the correct answer, option letter B, because it is greater than 0.0051 and is less than the upper bound 0.038. Okay, so always start from the bigger number and then find the greatest number that's smaller than it, and that should be the answer because the next number after that middle term should be your lower bound. In this case, is 0.0051. All right, let's take a look at question 41. It says, Abby drives 18 miles round trip between home and work each day. If her daily round trip is rounded to the nearest 5 miles, which of the following is the best estimate of the total number of miles in 5 days? So let's go ahead and carry out the rounding of this number right here. So if we're rounding by 5 miles, what does that mean? Well, it's just like a number line counting by 5s. Okay, so if we're counting by 5s, what two multiples of 5 does 18 fall in between? Falls between 15 and 16, 17, 18, 19, 20. Okay, so 18 falls between 15 and 20. All right, so if we're rounding to the nearest 5 miles, are we going to round to 20 or are we going to round to 15? We can clearly see that 18 is closer to 20 than it is to 15, so we're going to round 18 to 20, okay? So 18 is equal to 20 miles to the nearest what? 5 miles, all right? So that's 20 miles a day. So for 5 days, let's see, we have, or she drives, the mileage per day to the nearest 5 miles, which is 20, multiplied by the number of days, which is 5. 20 times 5 is 100 miles. And your final answer is option letter B. All right, let's take a look at question number 42. It says, carry around the same distance in 4 different races. Her times were 18.04 seconds, 21.39 seconds, 12.99 seconds, and 14.14 seconds. If the individual times are rounded to the nearest 1/10 of a second, what is the estimate of Carrie's total time for all 4 races? Okay, so the 10th of a second is the digit right to the right of the decimal point. So what we're going to do is write down the times in pairs, round them up, add them, and then we keep adding numbers from there. Okay, so we have 18.04 and 21.39. So let's go ahead and round these two. If we round 18.04 to the nearest, this is the 1/10 of a second right here. 1/10 of a second. We're rounding to this decimal place and that decimal place. Okay, so you look at the number, the digit behind the 10th place is 5 or greater, you round up. If not, you truncate. Okay, so this one is 18.0. You just truncate the 4 This one is 21. The second time is 21.4. You round up since 9 is 5 or greater. All right, we're looking for total time. So let's add these two. When we add them, we have 39.4. The next time is 12.99 seconds. We're rounding to the 1/10th place. So 9 is 9 or greater, so we're going to carry 1. And then this becomes 10, carry 1 again. This becomes 13.0 to the nearest 1/10th of a second. We add this down. 4 plus 0 is 4. 3 plus 9 is 12. 2, carry 1. 1 plus 3 is 4, plus 1 is 5, 52.4. And the last time is 14.14 seconds. So we round to the 1/10th place. So we have 14 point. We're going to truncate here because 4 is less than 5. All right, and then the final answer we get by adding 0.5. 2 plus 4 is 6. 5 plus 1 is 6. 66.5 seconds is the time. Our answer is option letter B. All right, let's take a look at question 43. It says, use the information below to answer the question that follows. The grocery store is located 3 miles away from the house. The house is located 4 miles away from the highway. Based on information about which of the following conclusions can be made. So the distance is provided, but we're not told if it's to the north, south, east, or west, okay? So we're just going to assume a radius, okay? So let's start with the house. I'm going to color code here, okay? So this is house. I'm going to call that HOU. This point right here as the house, okay? So we're going to make a number line to represent our distances. Okay, so I'm going to use 2 tick marks to represent 1. All right, so the distance from the house to the grocery store, so it says, actually it mentions the grocery store first. It says the grocery store is located 3 miles away from the house. So let's start with the grocery store. We're going to call that GR. So that's grocery store. So 3 miles out, 1, 2, 3, we have the house. Okay. So let's make that green. So this is the house. Because this is the position of the possible position of the house right here. And then we then go another 4 miles from the house to get to the highway. 1, 2, 3, 4. Okay, so this is the highway. Hi. So is this exactly how these 3 locations are oriented? The answer is no, because it's not indicated here. So since only the distances are provided, what we're going to have to do is we're going to assume as a radius, okay? And then we can apply certain constraints to it. So if the house is 3 miles away from the grocery store, what does that mean? It means that if you go 3 miles out from the grocery store, in any direction, you could possibly locate the house. Okay, so that's the distance of the house from the grocery store. All right, so the reason we're using the circular representation is because we're not told exactly how they're positioned, okay? All right, now how about the distance from the house to the highway? It's 4 miles. In what direction? It is not specified. So starting from the house, we draw a circle of radius 4 to the highway, okay? All right, so what does this mean? It means that the highway could be located anywhere, any point on this circle right here, okay? So this is the collection of points that are 4 units away from this central point right here, namely the position or location of the house. Okay, so with this sketch, we could make some conclusions, right? For example, this could be the location of the highway. You see, the closest distance between the highway and the grocery store is 1 mile, whereas the farthest distance between the grocery store and the highway is 1, 2, 3, 4, 5, 6, 7. So you see that range there? That's something we can determine based on the construction of this circle. Okay? All right. Now, with that in mind, let's see what statement is true. Statement A, grocery store is no more than 3 miles away from the highway. But we can see that the maximum separation from, let me make it clear for you, the maximum separation from the grocery store to the highway is a total of 7 miles, okay? That distance there is 7 miles. We already established that. So is that statement true or is it false? That statement is clearly false because 7 is greater than 3, okay? So maximum distance is max, which is 7 miles. Okay, so I eliminate A. Option B, the grocery store is no more than 1 mile away from the highway. That's even worse. That's the closest distance. The farthest distance is 7 miles, so this is false also. Option letter C, the grocery store is no more than 7 miles away from the highway. Excellent. You see the maximum separation from the grocery store and the highway is when they're collinear and the distance is 7. Our answer is option letter C. All right, let's take a look at question number 44. It says, use information below to answer the question that follows. It says if the distance to a destination is greater than 10 miles from home, then Max will drive his car. If the distance to destination is greater than 2 miles but less than 10 miles from home, then Max will ride his bicycle. If the distance to a destination is less than 2 miles from home, then Max will walk. So this is the question. If Matt rode his bicycle to Zachary's apartment, which of the following statements could be true? All right, so let's sketch the situation that we're looking at here. So we're going to put it on a number line, okay? So the starting point, this is the starting point. This is the location of Matt's house, okay? So this is Matt's house. Now, if it's 10 miles or greater, he's going to drive. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, I take that back. If it is greater than 10 miles, so we're going to put an open circle here. Anything to the right of there, guess what? He's going to drive. Okay? Now, this is 10. If it's between 2 and 10 miles, okay, he's going to ride his bicycle. So 1, 2 right here. So from here, let's put it here, from 2 all the way to 10. If the distance falls anywhere in this range, Matt is going to ride his bicycle. All right, so from 2 to 10, Matt is going to bike. Okay, and then between 0 and 2 miles, from home to 2 miles out, anywhere in this range, right here, Mike is going to walk. Okay. Okay, so the situation here is that Matt rode his bicycle to Zachary's apartment. So what does that mean? It basically means that Zachary's apartment is anywhere between 2 and 10 miles. Okay, so let's write an inequality representing that situation. So let D be the distance from Matt's house to Zach's, okay? So the inequality that will satisfy the given condition here is that 2 is going to be less than D, and D is going to be less than 10. So any value that satisfies this inequality is a feasible distance between Matt and Zachary's apartment, Okay. All right, so let's see which of the statements could be true. It says Matt's home is less than 1 mile from Zachary's house. So D equals 1. Does that satisfy this inequality? The answer is no, this is false, because it falls 1 is right here, which is outside the interval. So we eliminate option 1. Option 2, Matt and Zachary live within 2 miles from each other. D equals 2. Does that work? Right at this boundary point, you have 2 open circles. Okay, 2 is not included, so that is false also. All right, eliminate that. And then 3, Zach is about 7 miles from Matt's home. D equals 7. What do you think about that? 3, 4, 5, 6, 7, right here. That's perfect. This is true because 2 is less than 7 and 7 is less than 10. So it satisfies this inequality. Hence, that statement is true. Our answer is option letter C.